Okay, so now we're going to look at variable expressions and equations, okay, which is just some basic exponential properties. We're going to start throwing in some x values in there, taking a look at those, looking at order of operations, things of that nature is what we're looking at in this section. Okay, so starting with exponents, we have two different pieces to an exponential expression here. We've got your base, okay, which is the bigger number, okay, and this is the base, and then you have, of course, the exponent. Okay, most of us should know what an exponent is. A lot of us don't realize that this other part is called the base. That's going to come in very handy later on when we start looking at logarithms. Yes, we will do logarithms in this class. Now what this means, 2 to the third power, means 2 times 2 times 2. Okay, the exponent tells us how many times we're multiplying the base by itself. So 2 times 2 times 2, which is 8. Does not mean 2 times 3. Please don't do that. If they wanted 2 times 3, they'd write 2 times 3. Okay, this is 2 to the third power, which is 2 times 2 times 2, which is 8. Okay, not 2 times 3. That means not equal to 2 times 3. Okay, so please keep that in mind when you're going through these. That tends to be, usually that's just a very moving too quickly kind of mistake. Most people don't think that it's actually 2 times 3. Usually it's just a moving too fast. But just to make sure that we're all clear and we're all on the same page, this means 2 times 2 times 2, 3 times. Okay, so for instance here, 3 squared. First of all, evaluate, when you see this, and you're going to see it a lot in this class, evaluate really just means solve, per se. Okay, it means find a value. They want to know what is 3 squared. Okay, the reason why they use evaluate, not solve, is because solve usually means that there is first of all, it means there's an equal sign. We have an equation instead of an expression. This is an expression because there's no equal sign. And when we look at equations, we solve equations. We evaluate expressions. So that's kind of the difference. But it means the same thing. They want to know what is 3 squared. Well, it just means 3 times 3, which is 9. So that's what it means to evaluate that value, okay? Again, it's not solved because we're not, like, there's no x in there that we're trying to find. They just want to know what is that actually equal to. Okay, so 5 to the third power, okay, which means 5 times 5 times 5, which is 125. And some of these you'll get so good at because you'll just see the same numbers over and over again that you'll just know that 5 cubed is 125. Okay, 7 to the first power, okay, that means 7 multiplied by, well, it just means itself once. Okay, so 7 to the first power is just 7. Okay, anything to the first power is just itself. Okay, 3 sevenths squared means 3 sevenths times 3 sevenths. Well, the last section we learned how to multiply fractions. 3 sevenths times 3 sevenths, multiply across the top. 3 times 3 is 9. 7 times 7 is 49. I know they don't reduce because these were all prime numbers and none of them reduced, so that's just my answer, 9 over 49. Okay, so that's kind of how exponents go. You should be very comfortable, but we just wanted to run through it very quickly. Okay, order of operations. We should be very good at this as well. This is going to be one of the most important things you do in my entire class. Okay, because if you don't know your order of operations, okay, then so many of the topics that we're going to discuss in this class are going to come out wrong. Okay, you're going to put them in you have to understand order of operations to put things in your calculator properly. To be able to evaluate things properly, you need to be able to do order of operations. Otherwise, you're going to get things wrong a lot in this class. So make sure you understand order of operations. Okay, and we start with PEMDAS, right? Hopefully everybody recognizes PEMDAS. It is parentheses. Okay, which is parentheses, actual parentheses. We can also use the squiggly parentheses, okay, or the squiggly brackets. We can also use the square brackets. Those would mean the same thing, okay, or any other type of grouping symbol. Okay, it's not just parentheses. Any type of grouping symbol is going to act as a set of parentheses. So you do what's inside of the parentheses first, okay, and then we have exponents. Those are going to come next, okay? So we're going to evaluate those exponents next, okay? Multiplication. So multiplication comes next, okay? So like x times 2 times 3, you're going to multiply these things together is going to be that order there. Okay, so 2 times 3 is 6 times x would be 6x. That's your multiplication. Okay. Sorry, let me rephrase this here. That's a multiplication symbol. That is also a multiplication symbol. Reading my own notes, can't read them. Okay, these are 2 different multiplications, and this also means multiply. These are 3 different examples of multiplication symbols. Okay, division. Okay, division means either that symbol or you have that, which is a fraction bar. Those are both division symbols. Okay, and when you're doing these happen basically at the same time, and they're going to be left to right. Okay, so when it's just multiplication and division, you just work left to right. Okay, multiplication doesn't necessarily come before division or vice versa. They're the same step, and you just go left to right with these. Same thing with addition and subtraction, which is our last 2 here. Addition, everybody knows what addition looks like. Subtraction, everybody should know what subtraction looks like. Okay, and these are also going to go left to right. Okay. If fraction bars are present, simplify the numerator and the denominator separately. So you simplify the top, you simplify the bottom, and then you divide them out. Okay, if absolute value bars are present, they serve as a grouping symbol. So remember, absolute value from the very first lesson of this unit looks like this. Okay, they will act like parentheses in the beginning. So as far as order of operations go, those are parentheses. So anything in the absolute value, you do the inside first, and then you move from there. Now there's some restrictions to working with the absolute value, but we'll talk about that more when we do those. Okay, but for the most part, you're going to be, when we're talking order of operations, they act like parenthesis symbols. Okay, so looking at A, okay, order of operation, I've got 3 times 4 squared. Okay, exponents comes before multiplication, which means I must do this exponent. I cannot do 3 times 4, which is 12, raised to the second power. That is not the correct answer. I need 3 times 4 squared. The only thing being raised to an exponent is that 4, because that's the only thing it's touching. So this means 3 times 4 times 4, which is 3 times 16, which is 48. Okay, so that one's going to be 48. Okay, here I've got multiplication, subtraction, division, and addition. So multiplication and division must happen before the addition and subtraction. Okay, so we've got 3 times 10 is 30. 7 divided by 7 is 1. Okay, now it's addition and subtraction, so now I just go left to right. 30 minus 1 is 29, plus 2 is 31. Okay, just left to right after that. Notice when I did multiplication, I just went left to right. Okay, 3 times 10 first, 7 divided by 7 second. Okay, so same thing here. Now you have to be careful. I've got all kinds of parentheses and brackets and stuff. Okay, you start with the innermost set of parentheses. Okay, so right here I'm just going to write down the rest of the stuff. Notice I did not add 4 and 2. Addition is the last thing that happens, so we can't do that first. We're going to do 10 minus 1 is 9. Okay, now I'm working at this set of parentheses. Okay, so 4 plus 2 times 9. Well, within this set of parentheses, multiplication happens next. This means 2 times 9. Okay, so I've got 3, 4, plus 2 times 9 is 18. Okay, now this does mean multiplication, but you have to remember I'm still working inside a set of parentheses. The inside the parentheses has to happen first. So now I've got 4 plus 18, which is 22. Okay, and now 3 times 22, because this means multiplication as well. Okay, it doesn't matter if it's brackets or parentheses, that means 3 times 22. So 3 times 22 is 66. Okay, let me do that one more time for you. I started with the innermost set of parentheses here, 10 minus 1, which is 9. Now I'm working within this set of parentheses, because parentheses comes next, but within my set of parentheses I also have to look at order of operations. So I've got 4 plus 2 times 9. Okay, well, multiplication happens first, so 2 times 9 is what I did. Okay, 2 times 9 is next. Okay, and then I'm still inside parentheses, so then the next order of operation is plus, so 4 plus 18 is 22. Okay, now that's all I can do inside that set of parentheses. So once that's done, now we move outside of the parentheses, which gives me 3 times 22, which is 66. Okay, now D, we're going to have two separate pieces here. Okay, we've got the top and the bottom. It says that if there is a fraction bar present, simplify the numerator and the denominator separately. So let's start on the top. 6 divided by 3 plus 5 squared. Okay, looking at the top, order of operations says exponents first. So I'm going to have 6 divided by 3 plus 25. Okay, and we're going to do them at the same time because they're done separately. Okay, so here, inside of the parentheses must happen first. So 1 minus 4 needs to happen. So 1 minus 4 is negative 3. Okay, so now going back to the next step on the top. Okay, I've got division and addition. Division comes first, so 6 divided by 3. Okay, 6 divided by 3 is 2. Okay, and on bottom, I've got the absolute value of negative 3. I can go ahead and do that now. Now, this is where absolute value is different, is because now I have to treat them like absolute value, not like parentheses. The absolute value of negative 3, going back to that first lesson, just means that I get rid of that negative, so I get positive 3 on bottom. Okay, so now I get 2 plus 25 is 27 divided by 3. Okay, so very last step, 27 divided by 3. Top is simplified, bottom is simplified. Now I divide. 27 divided by 3 is 9. Okay, going back on top, exponent first. Okay, then division. 6 divided by 3 is 2, and then addition. 2 plus 25 is 27. On the bottom, inside parentheses, 1 minus 4 is negative 3. Okay, then evaluate the absolute value. Absolute value of negative 3 is positive 3. Okay, and then very last step, we divide the entire fraction. 27 divided by 3 is 9. Okay, so that is the front part here. Well, no, you still have another part on the front, which is the evaluating algebraic expressions. Okay, this is probably the bottom of your page. Okay, so evaluating algebraic expressions. First of all, I kind of sort of talked about it, but let's get a little definition. The algebraic expression is a collection of numbers, variables, operation symbols, and grouping symbols. Okay, numbers, variables, operation symbols, and grouping symbols. So numbers are just numbers. Variables are x's, y's, z's, whatever else you want to throw in there. Operation symbols are your adding, subtracting, multiplying, dividing, square root things, stuff like that. And grouping symbols would be your parentheses, your brackets, your absolute value. Absolute value kind of fits under both categories there. Okay, so it's just a collection of those things. So for example, 2x is an expression. Negative 3 is an expression. Okay, 5p squared plus 1. Those are all expressions. Okay, now what I do want to point out is that notice there is not a single equal sign. Okay, when you throw an equal to something, now you're talking about equations. Equations have equal signs. Expressions do not. That's the difference. Okay, expressions do not. Alright, so evaluate each expression if x is equal to 3 and y is equal to 2. Okay, to evaluate, you're just going to substitute. So again, here's that word evaluate. Okay, we're doing evaluating because we're talking about expressions. There's no equal signs. Okay, so we're finding the value of 2x minus y if x is 3 and y is 2. You just substitute. Okay, so if x is 3, I put a 3 instead of x. So that's this was 2 times x. So now it's 2 times 3 minus y was 2. So instead of minus y, we minus 2. That's all it is. It's just substitution. Okay, and then order of operations. Multiplication first. And then 6 minus 2 is 4. Okay, That's all you are doing, okay? Big thing here is that order of operations. Make sure you stay consistent with it. So here, substitute. So instead of 3 times x, it's 3 times 3, because that's what x is equal. Instead of 2 times y, it is 2 times 2. Okay? 3 times 3 is 9. 2 times 2 is 4. That would be your answer. Okay, same sort of thing in that next one, x squared minus y squared. Okay, so if I've got x squared, that's going to be 3 squared minus 2 squared. Order of operations, here we go. Okay, exponents have to happen first, so 3 squared is 9, 2 squared is 4, and then 9 minus 4 is 5. So that would be your answer there. Okay, so that is really all there is to the algebraic expressions, evaluating them when they give you certain values to look at. Okay, they won't always give you values to look at, and we'll talk about those later on. But that's really it. It's kind of basic. It's just a substitution process, which hopefully we're pretty familiar with. Okay, so that next part, an equation, and I kind of already talked about that, but now we're going to define it. Contains the equal symbol. Okay, it's an algebraic expression. Does not contain an equal symbol. That's the difference. Okay, you cannot solve for variables if there is not an equal sign. This right here is super, super important, because I see students do this all the time, where they have an expression. Okay, so you have something that's not set equal to anything, and it says, and then you magically start solving for x, and you just set these things equal to whatever you want to set them equal to. You can't do that. You can't just decide that an expression equals something particular. Okay, so we can only solve for variables if there is an equal symbol. If there's no equal sign, then you just evaluate it any way you can. Usually that means simplifying it down to the smallest term that you can, and then you just leave it alone. Alright, so let's look at some algebraic expression words. Okay, so this is just this is going to be just an example list. Okay, there's obviously a lot more things. So when you think addition, there's lots of words. Sum, plus, added to, more than, increasing, increased by, total. Okay, so all of these things are words that mean that that tell us that we're adding. They're key words that say this, we should be adding here. Okay, because we're going to take a look at converting words into algebraic expressions or equations here a little bit. Okay, so we need to get a good idea of some key words here. So subtraction. Okay, subtraction is the difference. Okay, minus, that of course means subtract, subtracted from, less than, decreased by. Okay, just less. These are just some examples that you can go by. There are a lot more. Multiplication is product times, multiply, twice, okay, 3 times, those usually have the times in them, but twice, okay, of, in mathematics usually means multiply, of means multiply, okay, per or each. Okay, those a lot of times tell us multiplication as well. Sometimes those can fit into the division. Sometimes they can fit into the division. It just kind of depends on the way it's worded. But those tell us a lot of times multiplication as well. I'm actually going to fit it into both categories here. Okay, miles per hour means divided by hour, miles divided by hours. But a lot of times it's telling us that we need to multiply as well depending on what we're looking for. So keep that in mind. Division, we've got quotients, divide, into, ratio, divided by. These are all good division. Okay, those are all keywords that tell us we're division. Now equality, they can say that they're actually equals, or it gives, is, was, or should be. Okay, is, was, or should be. Yields is a good equal sign. Amounts to is the same as. Okay, again, these lists can go on and on and on and on in different forms of saying these exact same thing, different tenses of the exact same words. There's lots of other words as well. But this is just kind of just a basics. This has got some of the keywords in it that you're going to see a lot. All right, so writing algebraic expressions or equations for the following phrases. The sum of a number and 3. First of all, anytime you see a number, you need to just give yourself some sort of variable to put in there. So the sum of a number, I'm going to put x. Okay, sum means add. Okay, sum of a number and 3 means x plus 3. Notice I don't put equal to or anything. They didn't say it was equal to anything. They just said the sum of a number and 3. That's how I write that expression. Okay, 10 decreased by a number. So we start with 10 and we decrease it by some number. Okay, 10 decreased by a number. Okay, I would suggest you hit pause and see if you can't get these other 3. Okay, see if you can get the same answers as I do. Hit play. See if your answers match up. I'm going to keep on going. Okay, 5 times a number increased by 7. So if I have 5 times a number and then comma increased by 7. So 5 times the number then increased by 7. Okay, the next one, the quotient of 15 and a number is 4. So the quotient means divide. So quotient of 15 and a number is. Is means equal. Okay, so this one is actually an equation. They actually said this is 4. Okay, so 15 over x equals 4. 8 less than 3 times a number is the same as the number increased by 2. Now here you got to be careful. Now a lot of you might have written 8 minus 3x. Okay? But you have it backwards, because if I want to be less than something, I have to start with the something. Okay? I want to start with the something. So we have 3 times a number and then 8 less than that. Okay? If I want to be less than something, I must start with the something, and this is the one that throws people off the most. If I want to be less than something, I have to start with the something. If I want to be more than something, I want to start with the something. Okay, so 8 less than 3 times a number. Okay, 3 times a number, 8 less than that, is the same as, okay, that number increased by 2. Okay, the same as the number increased by 2. So that is writing algebraic expressions or equations from phrases. Okay, writing expressions from phrases. That's a skill that is going to help you out tremendously throughout this class as we do word problems and things like that. Okay, that's the end of that lesson.